Alrighty folks, we're going to be doing free response question 1. This is the particle question having to do with acceleration, velocity, and displacement. It says a particle moves along the x-axis, so its velocity at time t is given by this over here. So the first thing we want to note is this is a rate equation. Okay. Question A, and then it says here at time t equals 0, the particle is at position 1. So that's kind of like the initial value, right? So it says, part A, it says find the acceleration of the particle at time t equals 2. Is the speed of the particle increasing or decreasing at t equals 2? Why or why not? So there's 3 questions there, so we're going to answer those 3 questions now. So for part A, want to find the acceleration, so we need to remember that the derivative ddt of velocity v of t equals acceleration. Okay. Also, the derivative of, notice I'm taking it with respect to t, of the displacement, I'm going to call it x of t, is just the velocity over here. So these are just old stuff here, so we really need to find the d dt of v of t here. So, and then you just plug in at t equals 2. So basically you take the derivative and then plug in 2. You should pause this and try it out real quick. And if you notice, this is the first part of your free response question. So you have an option. You can take this derivative, but if you look at this derivative, it's kind of complicated. Just do it in your calculator. If you have the option, in this case you do, so I would do it. So go ahead and input it in here, because you don't want to make a mistake. As you all know, differentials can be quite time consuming and it's easy to mess up. So let's put in, this case it's going to be x plus 1 over here, because x is takes the place of t times the sine of t squared, or x squared divided by 2. And I'm going to check my mode to make sure I am in radians, or is it going to mess up? I am in radians here. Go back to y equals. I'm going to hit second calculate, and I'm going to go to dy dx. I want the derivative, and the function is going to give you this here. If you notice, this is graphing this function here, v of t, and your window has to be visible in the point we want. We want t equals 2, so plug in 2 here, and you should get this. So in this case, so you can either say it like this, v prime of 2, or you can say a of 2 equals, or is approximately actually 1.588. And they don't give units, but you should put units per time squared, since it is an acceleration. Units per time squared here. That's part A. Part B says find all times. Oh, sorry, we didn't finish part A. So that's the first part. Is the speed increasing or decreasing? So here, increasing or decreasing here. What does that mean? How do you know if something is increasing or decreasing? If we recall, it is if a of t and v of t are the same sign. What does that mean? That means that they're going in the same direction. So like, if the velocity tells you where you're moving, and the acceleration tells you how fast. So if they're the same sign, then they're speeding up. This implies the particle is speeding up. Okay, that's cool. So we just have to find the velocity at 2, because we already have the acceleration here, right? So if you notice, a of t, or a of 2, is greater than 0, right? So his sign is positive. So now we just need v of 2. So go back to your calculator, go to y equals, and this time we're going to go to second calculate. And we want a value. So hit value or 1, and we just want the value at 2. And you can see here we have a negative. So v of 2, and notice you don't even have to calculate it. V of 2 is less than 0. Thus, since they're not in the same direction, the particle is not speeding up, because a of 2 and v of 2 are different signs. Okay? Okay, cool. And then finally, why or why not? We've already answered this part here, so part A is done. I'm going to move to part B on a separate sheet of paper, okay? I would recommend you do the same. So part B says here, find all times t in the open interval from 0 to 3 when the particle changes directions. So changes directions. So if you remember to change direction, you have to stop, right? So that's one of the key elements here. So we're going to go ahead and figure that out, and we have to justify our answer. So there's two parts. We have to answer it and then tell us why it's true. So changes direction implies v of t, or I should say particle stops. And when it stops, this implies the velocity. Clearly, you have to be 0 for this to occur. So basically, we need to find the roots of v of t, which is cool because we already have it in our calculator here. So let's go back. Again, we go to second calculate, and this time we want the 0. And if you remember, what's our interval? Because look at this graph, it's like all over the place, right? There's infinite number of roots, and it looks like there will be as this goes on to infinity and positive infinity and negative infinity. So our interval is from 0 to 3. So then we just check from 0 to 3. What I like to do is I want to change my window here. So let's go to window, the x min, let's make it 0, and the x max, let's make it 3. So that way I'm just looking at where I want to see, or what I want to see, excuse me. And we see this curve here, and it looks like clearly that it hits 0 over here somewhere. So the only real 0, and on the AP test they're going to be pretty obvious as to which one they want you to circle. So in this case it's this value between 2 and 3. So let's go to second trace again. We're going to go to 0, and we go here, and we want to go left bound. So let's just go kind of close to the 0 on the left, and let's hit enter, and let's go to the right, enter, and then let's go back to the center, hit enter again, and here we have excuse me, the 0. So this occurs at, so the particle stops at t is approximately, looks like 2.507, right? Because to change direction, v of t, or the velocity, must go from positive to negative, or vice versa. And you can see here, folks, that this occurs, it goes from negative to positive, so clearly this occurs at t equals 2.507. Okay, there you go. Excellent. And there you go. One of the free responses is done. Please try number 2 by yourself. The answers should be posted.